Okay, let's get back to terminal emulator. So, um, yesterday we got pretty far with the terminal emulator. We're now blitting text. We're parsing um, basic escapes. Basically, we're only parsing the color escapes. And we can draw like a few lines on the screen, but we're not like properly tracking anything. I can show that here if we just cat the source code. We'll get some lines blitted. And yeah, none of it's like correct. You can see like stuff like there's like I guess there's like a carriage return here or a new line. I'm not actually sure. I think it's carriage return, or I think it's a new line. And we're just converting that to a space, but still advancing the line. So we don't want to do that, obviously, necessarily, in the long run. Um, and got that going. Now, um, before we just get added, properly handling the um, cursor and stuff like that, and calculating the number of lines and stuff that's just on the screen and like how much space. So like here, we're not even figuring out like, is there enough space for the line? If there's enough space, we're just blitting right to the edge of the buffer, and actually off the buffer. So we don't want to do that, but we'll fix that after. But I happen to notice this, and we will demonstrate it. So if we launch this in the debugger, and I go ahead and prepare. Oh, that's not a good example. I don't know if there's enough characters there. And I just did it again. We'll have to add backspace support next. So prepare to do this, and then we go to the source file where we read in from the terminal. I believe that would be here. Yeah, sorry, it's in here. It's in this loop. So if I plop down a breakpoint here, so there's data available. We'll go over here, we'll press enter. Actually, we're in the syscall. We'll press continue so that we actually go to the correct breakpoint. And we follow this through, so we're gonna skip over that line. We're gonna hop into this call, and we're gonna go next. As you can see here, even we can make it more clear. We only read 4095 bytes. Now I'm trying to avoid that because this ring buffer has enough space to just read 16 million bytes at a time. We don't want to just read 4K, and the way we're set up right now is we just exit this function, finish. I don't know why finish doesn't work in this program. If we just exit this function, what we're going to do now is we're going to actually go through and blit lines, but there's like still more data that's just available. So if I do a continue, and we continue until the next time we just hit this, there's still data available, so we'll see what happens. So as you can see here, we just only blitted like half of where we should be because we haven't finished reading the data yet. So if we go and step back in here again, oh look, we read another 4095 bytes, and we're just going to keep doing that over and over again until we've read everything. Now that kind of sucks for like, this whole loop was just set up to be like run really fast. I hope that's not dropping frames. This whole loop was just set up to be run really fast. Where if we go to terminal.c here, where we actually deal with this data, where we parse it into lines, we're just set up here to just read tons of data really fast. This split long here doesn't actually exit the loop, right? This split long only does it's only for splitting a line in progress, but then we still go back and continue this loop until we've just processed all the data we've read in, like all possible data. So what we want to do is fix that, and we want to read. Basically, we want to make sure we just read until all the possible data's been read out, or we've hit the maximum ring buffer size, and then we'll just go through and we'll have to read more later. So to do that, let's start by the first thing you might think to do would be to go into here and read from child, and sit here in a loop and just go while data available, read more data and just keep incrementing this. And that's probably what we have to do just from my prior experience. But there's one last thing to just try here. So here, where we've spawned this new terminal, we've set the termios to raw, and raw input is not supposed to do any of this like weird buffering and stuff like that. But all this has done is set it for from the child's side. So when the child just goes to write to that file descriptor, like its side of the file descriptor, it doesn't see any buffering or anything going on. But I'm thinking that possibly we should be setting this on the parent side as well. Which basically means we should take this, we've already got the raw thing, and we've got this child file descriptor, so we'll just try to set that on our side. So let me zoom in here. This is readable, hopefully. And we're gonna do a man. I don't think it's this one. It's gonna be. Let's just go to termios.h for now. And I'll make this a little bigger so it's more readable. So here we have. Let me see. So there's like TC get adder, and then there's TC set attributes. So we're gonna do this. So set the parameters associated with the terminal. It takes the file descriptor. It takes optional actions. So it says when, basically it just tells it when these changes should occur. We are just gonna make it occur immediately. And then it takes like this struct to the termios. So we wanna make it raw. We'll try this. It might work, it might not work. I'm not 100% confident it's gonna work. But anyways, we'll do that after here. We'll go ahead and try this. And also, I guess we can also try this as well. Child file descriptor, set now, and we'll pass in the raw. That equals -1. We'll try this, but anyways. Let's see what the return values are. We're not going to bother with that. We'll just try that. So compiled, and I'll have to, oh, actually, we have to just restart the one in here. So you get rid of that first. Okay, so get ready for, need to type this without typoing. Let's prepare for that. So if there's new data available, we'll continue for now. We'll press this, we hit the breakpoint, and we'll step in. And let's see how much data. My guess is 4095 bytes again, because Linux likes to do what it likes to do. Hey, look, it's 4095 bytes again. So what that means is that all of that setting raw is just useless, and we can delete it. Or I don't think it's going to really have any effect on what we just have sent to us. Let's just continue. I don't see like any difference here, so I think we're just going to delete that code, and then we're going to go to that read from child and just read oops in a loop. So go back here, not here, go here. We will stop doing this. It's just a waste of time, clearly. So we'll stop doing that. And we'll delete this. And then in read from child, so in read from child, we are going to I don't know if we should like take into consideration the unprocessed bytes. I think not. I think if you just continued, I think, yeah, I don't think we care about unprocessed bytes if you just, so like, let's say for whatever reason, the terminal gets like half of the bytes, and then we process it, we figure out we need more bytes, and then we go back into this function and we just read 16 megabytes worth of data. I don't think we care about the leftover stuff from before at that point. If that were to happen, I think it doesn't matter. So I'm gonna just maybe put a to do and say check if we need to care about that. Probably we don't. So let's put a to do. Check if we need to care about unprocessed bytes from the last run. That's good. Okay, so here we're going to size remaining equals ring buffer to capacity. And then we'll say do while r does not equal -1. The size r up here, so we'll do r remaining. Go into here and get rid of this. Okay, so then we're gonna do this plus write IDEX. Read. Yeah, plus write IDEX plus r. So we should initialize this to 0. Capacity it should just be remaining. And then after we do the read, we're going to do remaining minus equals R. And that should do the trick, if I'm not mistaken. Obviously, we need some semicolons and stuff going on here. Okay, so after that, what we'll do is we'll say we need to figure out how much we actually read. So we'll go ahead and do so RB to write IDEX. No, we're actually doing that here. Sure. But we can't have this assert here anymore because it could be -1. We don't care about that. We're going to do RB to cap minus remaining. So we just started out at RB to cap, and then so RB to cap minus the remaining after we've done all our reads. Should be the total number of bytes we just read. And then, so yeah, we'll do that and do that here as well. And then we can go ahead and do our like clamping thing. That shouldn't change. And these asserts should be fine. Total bytes read. And total bytes read. And then we will return total bytes read. So because we set like the file descriptor to be non-blocking, if there's no data available, then we'll get -1 back. We could technically check error no to make sure that, you know, what we were expecting just happens, but anyways. So that should be better now. So we'll do the compilation here. And we will make sure there's no breakpoints. And we will run. And we'll prepare. What's happening? Hello? What did I break? So we're still just... we are locked in some loop there. So what did I break? That's all good. The only problem here though is if R returns -1, that's gonna screw that up a little bit. We'll have to fix that. So I mean, we can just fix that easily. Should be the only thing different here. So Account for the final. Actually, we just put this here. If we just put that there, then we won't ever have that problem. Okay, so let's see. This one's actually still just working. Let's see what happened here. Maybe that was just straight up the error. It's quite possible that that was straight up just the problem with what I was doing there. So, okay, so let's prepare here to draw this. Can you enter? Now what we're gonna do is we're gonna step over that, step in, step over, step over. So we're gonna read 4095. Oh, that's a bug. This can't be plus R. This needs to be plus plus the total bytes read. Okay, so actually we'll rearrange this a little bit here. Unless we just want to do extra math in this loop, but I think just adding to total bytes read is the easiest. So let's move this around here. Let's delete that whole thing. Zero. And then plus total bytes read. So otherwise we're just gonna overwrite that last 4095. Or we're gonna end up accidentally overwriting some data. Okay, so file that. And we will kill this. And we will just delete this breakpoint. Run. Breakpoint. Continue. I don't know why it always does that when you set a breakpoint, but apparently it does. So then, oops, should have done that. Cat vtgl.c. Now we can set a breakpoint. Continue. Enter. So step inside here, do that. Yes, that is the terminal emulator. It is getting somewhere. We're not like doing anything. We're doing some stuff here to make it easier to debug, but no. That's fine. Okay, so here we are going to check this watch thing. So we read 4095, that's not 0. Let's put remaining. And let's put total bytes read. Okay, so we're gonna do some more reading. Yeah, this would be working. Should maybe post a link to this. It's like GF2, it's like a graphical wrapper around GDB. It's okay. Let's put it that way. It's okay. it's better than just using raw GDB because you can set stuff like this and you can look at like the memory and stuff like that without like a ton of hassle, but it has some bugs. um, okay, so we read that. Okay, so we read some more. This last read was a -1. Yeah, raw GDB is like I use it from time to time, but it's like it's not fun. So okay, so now we're gonna do this. The total bytes that we just read was 8,680, which is obviously more than what was buffered before. If we continue, there shouldn't be any new data being written, so I'll just actually do a continue here, and it should just split a couple lines. Okay, so it just split a couple lines, and we're still just running. So that's actually much better. That means we've just read the whole thing we're supposed to read and not just 4095 bytes. So we can kill this one for now. And I will restart this one. And then, and okay. So oh yeah, well that you're still gonna run into that problem with this one. Basically, if you ever want to debug anything on Linux, you just need to use -0. Like I've never gotten any other one to work without it shuffling the code around a bunch and being useless. Um, okay, so what are we doing here? We're gonna commit this because yeah. Sure. Oops. Oh, you should use Clang all the time. Clang produces like way better code than GCC. Like I was oh TCC. TCC is fun. Yeah, TCC is fine. Like it's not an optimizing compiler, obviously. It has some optimizations, but it's not like the same thing. But yeah, the compilation being so fast is like it's really nice. Um okay. Yeah, I don't think you can do it anymore, but like when TCC just like came out, one of its calls to fame or whatever was that you could um use it to boot the Linux kernel and like run like you would have it compile the Linux kernel and run the Linux kernel at the same time. Like you would launch TCC from like your like initial RAM file system and use it to compile the kernel. Okay, so let's take a look here. So we've done that. Yeah, yeah, it's the initial RAM file system. It's just a file system in RAM. Um, okay, so let's see. What should we do here? I think we should do this thing because this is going to be like a little important for moving the cursor. Actually, let's not do that yet. Let's move the cursor properly first. I think that's more interesting. Um, let's just cat something out here so we have some data available. And let's go to btgl.c. split line. Okay, so here is where we're actually pushing lines to the screen. Right now, if we just get it's both, let's put it that way. So it started out as a bug because I just accidentally set the background color, like the default background color, to be different from the default background of like the clear color. But then I realized it's actually helpful for debugging because it shows like when you're like replacing some character with a space where there shouldn't have been like a character there, or there should have been something else there. So like here, this is like some new line. There shouldn't be anything getting drawn here. So it's kind of useful to just keep it like this. At least for now, until we have something like working a little better. So here, it's a feature for development. It's a yeah. So if we get a carriage return, this is when we should be setting the cursor column to 0. And if we get a new line, the new line's a special case, to be honest. This probably is going to work fine for now, but it needs to be handled specially. Term to cursor row plus plus. Otherwise, we will do this thing again. Okay, so probably we don't need this one here. And here we do need the cursor getting advanced. And then in blit lines, probably we need to... I mean, I think we still need to do this, but just palm it out for now and see what happens. Recompile. Okay, so why is that like offset? Yes, that's why we still need to do this. This needs to still get set to 0 so it doesn't get offset. But we've now cleaned up some of those extra characters that were just getting drawn at the end of the line. They weren't supposed to be there. And then what should we do? So I'm just worried about leaving this stupid new line thing here because I know it's going to be a problem later on. It's specifically a problem when it gets to the bottom of the screen. So let me make a function called newline. Now, where should I put the newline function? I feel like that doesn't need to go in this code here. So actually we don't know how many characters are supposed to be on the screen yet, so I'm gonna punt on that. But I will do a tab. actually, this. So let's actually put that with this other code because we'll just call it push tab. Okay, so let me decide here. This is going to be like a global, this is going to be like a configuration variable. I haven't fully decided where I just want to store those yet. I think like I'm kind of a fan of the like ST like DWM style storing configuration things in the compilation itself. Because usually these aren't things that need to be changed at run, or yeah, like I don't want to like I don't think like parsing a file. I don't find parsing a file to be useful when you know you could have let the compiler just make sure it was valid or not, and typed. So probably we'll start with that. Let's just make a config.h, and this won't be the one that gets pushed, though it might. I don't know yet. Let's see. Tab stop. Call it global tab stop for now. And it's going to be 8 by default. It's got to be a whatever character U32. I mean, technically it can just be like a U8 because we'll do that. And we're going to include that from util. After these types are all defined, blah, blah, blah. We'll go here. No, we'll include it like right at the end. Oops. So all the tabs just disappeared because I started writing push tab, but right now push tab doesn't do anything. Okay. Anyways. So we need to figure out the amount of characters to the next tab stop. So what we do is we're gonna take column and then advanced is going to be equal to the tab stop minus the cursor column mod, or minus the column mod tab stop. And then we're just going to advance the column by the advance. Okay, and then we're going to put do here wrap cursor if it goes off the edge. So this should just work. There's like two things we could do here. So this is gonna leave like a gap of gray, light gray. Technically you could just push spaces, but I'm not sure that's useful. So we will just do this for now. That did not do what I was expecting. Oops. There's a spam of escape codes that I haven't handled yet. Okay, let us open that in the debugger and see why that didn't work. Yeah, I'm not sure why it didn't work. Do that cat util.c. We're gonna go into here and we're going to find push tab. The breakpoint, we're not hitting that yet. Continue, so we hit the breakpoint. Okay. Delete this. So the current column is 0. That's fine. That means we're just, oh yeah, sorry, that's fine. Tabs are usually at the start of the line. So then the tab stop minus the column mod the tab stop is 8. So we're going to advance the cursor by 8. Which means that the new cursor column should just be, let's do this, is 8. So then we go back and continue to switch. Now, why would that? Oh, right. Okay, I see what the problem is. So yeah, this is not correct. Where am I? Sorry. Yeah, so here, this rect, this cell rect, we need to advance that by, like, really, here, instead of doing this, we should just calculate where it should be. T to cursor column -1. There we go. Except we're missing the first character. Let me think here. So, oh, right. Because if the cursor is 0, so actually I don't think we need the -1 then, right? You just see, so this should be like monospaced, so 1, 2, 3, 4, 5, 6, 7, 8. Is that normally how much a tab, how the tab stop works? Let's just verify. 3, 4, 5, 6, 7, 8. That's still like a space. So yeah, that's correct. Okay. So now we've got tabs just showing. So that's good. What else? We should probably actually calculate the window size and do like some wrapping. Yeah, I think that's what we need to do. And if we just know the window size, then we can also do some stuff like setting the terminal properties so that the program, any program that's running knows how big the terminal is. So let's do that. Yeah, we will delete this part for now. And we will oh yeah, this is going to be a bug right now. That's okay. Actually, I think this here. I think these notes are just like incorrect for now. So yeah, I think these notes are incorrect. Also, let's actually handle backspace first so that I can actually type stuff properly. But first of all, so these notes, I'm going to leave a note here that just says, for now, we assume that we will blit the whole every time just every time is fine. For now, we assume that we blit the whole screen every time. And that means that these need to be reset here and here. Well, actually, this one is not, shouldn't be reset, but this one should be. So actually, this was only getting broken like the first time through. Let me see here, actually. We just move that outside the loop. Does everything still work properly? Yeah, there's like nothing that changed. So actually, that's fine. So let's actually restart this because I just want to make sure that it's also fine when there's only like a single line. Pressing the wrong ones. There we go. So yeah, that's looking good. Now we're looking at some stuff. That's nice. Let me see. Okay. Having a brain dump here. Let us handle the backspace. In this file. In what's it called? Key callback. So there's like a set of keys that need to be like re-encoded. If we go to like this old version of the code that I had, like a little big. Doesn't need to be so big. Key callback. Not this, sorry. Oh, also one other thing that actually with this hot reloading we can just check. So if we reload this and set the tab stop to 4, does this work properly? And it does. So that's cool. Yeah, I like tab stop of 8, but that's cool. So that just works. Let's look here. So right, so what we do is, well, that's for like actual control keys. That's a problem with our current implementation as well. Okay. I kind of like this encode thing, but I also think this encode thing is kind of worse for performance. Good. I can speak English. So let's actually look at what this encode keys thing was. Encode key. Yeah, this thing is definitely worse. So just by encoding the key like this, you're basically making it so that the compiler cannot construct like a jump table out of the keys, whereas like normally it would be able to just construct a jump table if you were handling most of them, or if you're handling all of them. I guess the question is like, are they all actually going to be handled though? And I think it's actually no. So in that case, then it doesn't even matter. Let me look at GLFW's key callback here and see what the keys are. Reference keyboard key tokens. Okay, so we only got like up to 300. Actually, these aren't even like. Okay, so that whole argument was just wrong. So these don't even like sequentially increase, so the compiler would never have made a jump table anyways. Because these like jump between different these like skip indices. So in that case, then this encode keys thing is like fine, and it kind of improves the readability. So I'm gonna actually copy this macro and do it again. GLFW does not sequentially numbered keys. So switch statement will never be optimized. Okay, so let me see here. Probably I can be a little bit more verbose here. Try a different hash variation. Yeah, I don't think any of them do that. Most of them can barely compile stuff to begin with, so without being like incredibly laggy. So we'll do this. We'll be verbose. Mod key action. I don't really want that on right now. That is horribly broken. Okay. So here we will do a switch on encode key. And I'll actually do the same thing I did again. So action mod key. So act mods key. Actually, sorry. For mods, I'm going to put 0 because sometimes you have the mod key held down and you should just ignore it. So like if you have shift and you type like shift backspace, it should just be the same thing. That's part of the reason why they're slow. Part of the reason why they're slow is because of the way C and C++ are defined as having multiple translation units, and therefore you need to have a ton of headers to just do, you have to like reprocess a bunch of headers over and over again. So that's the other reason why they're slow. Okay, so case encode key. Press. Oops. And also because the people who write them are not good at writing parallel code. So basically, like the C compilation model, they're just like assuming that you can't, that they'll just only process a single translation unit as a single threaded thing, and then you'll get like you'll get benefit for doing processing multiple translation units in multiple threads, but you could have much more optimization if you just process the whole translation unit in like the single translation unit in parallel. Okay, so key escape. Basically 0 here is like a don't care case. And we'll do repeat as well. This is what I had before. Yeah, okay. Wondering if it was like this wide. In this case, we're gonna set this and we'll break. Did I like have this? Yeah, I also did like the repeat case. Oh yeah, right. So like if you hold repeat, yeah, if you hold the key down, you should just be like like putting this over and over again. So yeah, that makes sense. So we'll go here and we'll do key enter. I'm gonna copy another set of these and we will do key backspace. There we're gonna do child put care. Um, 127, which is delete, if I'm not mistaken. Here I just did like 127 hard coded, but yeah, like so 127 is like 7F, it's like delete. Okay, so that should get us backspace support, if I'm not mistaken. Let me see here. Yeah, we'll deal with these other things later. Right, and we should do whatever. For now, we'll just say that. Now, if we go over here and we type cat, but we need to handle that now ourselves. So yeah, it did work, but we have to actually back the cursor up. So when the what's it called? When the child just responds with another backspace, we have to handle that. Let me see. Push line. I believe that's just it literally responds with this backspace. I don't think this is like the best way of handling this, to be honest. Yeah, so we'll have to write like a function like this because we need to make sure it gets clamped if it's gonna go before. Um, uh, for now, we'll do that. Actually, that's a funny case for hot reloading is that the cat thing that was here with like some extra stuff just ended up back getting shown. Anyways, we do this and we go backspace. That just works now, and we can put a T there and it will show up in the right space. So that's cool. Okay, so let me see here. So what should we do? So now I want to calculate the window size when the window's resized and update it. Let's do that. Is there an extra space there? Let me see. Let me just commit this for now. Yeah, let me take this commit. I don't want to add config.h necessarily. What's it called? Um, if, oh, sorry, if I think it's this. Sorry, I'm like doing something dumb here. So anyways, should just be that. Though there's like shell check. Anyways, if not that, copy config maybe. I'll just test this. Move config.h to config.def.h and then try to build. Oh, right. Shell scripting. Semicolon is needed here. Want to have a one-liner. Okay, so yeah, that's correct. Okay, cool. So that's what we want. Yeah. Config def.h. We'll do. Oops. Let's do this. Wait, does that not have a new line at the end? Oh, no, it does. Handle control chars in push line. Okay. Yeah, sorry, that spams that because I keep typing. Oh, and we're gonna do it over and over again. I should fix that. Right, that's, yeah. I'll have to fix that later. Okay, so let me see here. We are gonna go into here. Refresh callback. Not refresh callback, frame buffer callback. FB callback, sorry. And here we need to get the cell size. That's fine. I think I should. Well, excuse me, I need the child, right, descriptor to do this. Okay. I'm gonna add a new parameter to the terminal, the term struct, and that is going to be the the size in cells. Yeah, this is fine. So we just recompile this. We're gonna have to restart this. Somehow we're not having to restart this, but yeah, we're gonna restart it. Technically, that's like kind of an invalid state because the structure stuff moved around. Okay, so next we are going to we're gonna yeah, so here we're gonna do what's it called? V2 cell size equals get cell size. And then we're going to right, we're gonna say t to size dot w is going to be equal to t to size dot w is going to be equal to the width divided by the cell size. Yeah, that's correct. Cell size dot width. And then we technically need to cast this back to a yeah, we want this to be an integer. And then same thing for the height. And then let me see. So there's like another thing we need to do, which is I can't even remember what the function's called right now, so I'm just gonna have to look it up. Set win size. Oh, I see. It's literally an ioctal. Yeah. Okay. Why does this need to know the pixel size? The size in pixels. That's really weird. Anyways, so let me see if that's actually even covered in the ioctal. Oh, also this is like a Linux specific thing again. Yeah, interesting. Like Unix specific thing, I think. Huh. Okay, this is gonna go in the where is like the this is like gonna have to go in the OS specific code. Yeah, so like this is like code that I wrote previously. The main problem with the code I wrote previously is that it has like, well, the problem isn't that it has bugs. The problem is that the way it was structured was not like really good because I didn't really understand a good way of structuring the terminal program. Um, and it was structured in such a way that like I couldn't have this like hot reloading thing going on, which already has proven to be very, very helpful for developing. So additionally, I should say, um, I've already changed like a lot of things here. So like what we're doing right now, this pushing just stuff raw, pushing right to the terminal buffer. Um, in the old program, there was basically like a copy that was going on where we were like making a copy of this whole thing and then going through that copy and then like drawing a bunch of stuff, which I don't think is useful. I think that's probably just a waste of time and memory. Um, so mostly I just wanted to get the hot reloading thing working, and also I just wanted to restructure it so that it made a little bit more sense. Okay, so I'm going to copy this function. And we are going to do this. This is going to be called OS set term sized. Can't even remember like where this is just like defined, like which header. Like if I just look at it's gotta be like in pty.h. Not pty.h. Yeah, that one doesn't even have a POSIX man page. Yeah. Oops. Have a look here. So maybe in ioctl tty, do I have that man page installed? I do not. Let me just install normal man pages. Yeah, I'll just do that quickly in the background here. Okay, let's have a look at this. Ioctls for terminals and serial lines. Use of ioctl makes for non-portable programs. Yeah, but the thing is that using POSIX interface is also going to be non-portable. So, is this really an issue in practice? I have no idea. I've also seen this exact same code being run on OpenBSD before, so I don't really feel it's gonna make stuff unportable. I'm actually wondering if this can help with the buffering. Who knows? Let's go to this window size one. So yeah, this would be T ioctl set window size. So, oops. Let's go over here. Got our window size here. This is gonna need to take the terminal. key to size dot width dot height x pixel y pixel key to child key to child dot file descriptor set term size. Okay, so that looks fine to me. Let me take a look here. Need to call that actually, sorry. Frame buffer callback. Okay, we're gonna pass this in. We're gonna do OS set term size P X Y W H in pixels. Okay, so this should all be good now. Oh, yeah, that's kind of annoying. I don't want to have to, I don't want that to have to take the terminal. We're going to change that to take key to size and key to child. Take me to there. Okay, so we're gonna do OS child C and UV2 size. Okay, that's better. Okay. So now the window size is presumably getting set and restored. I guess we should check that. Get rid of this. Let's run. And we will just break wherever, it doesn't matter. Should like break somewhere that's actually gonna break. Okay, so let's take a look at the terminal now. So the size is 52 rows by 38 columns. That would seem reasonable given how this Windows aspect ratio and shape is. And then presumably the terminal properties for the child are just set properly so that they know that. So with that, I can probably start clamping the cursor and stuff properly. So let's do that. Let's do this. So we're gonna do we're gonna do function here called cursor move to or cursor move like basically I want two separate functions. I want cursor move, which is just going to clamp, and I want like cursor step, which is going to do like the proper it's going to do like the proper behavior in terms of doing like wrapping and stuff. Let me think actually. So when we do the backspace, let's do cursor move absolute. Pass in a t. We're gonna pass in a row and a column. How do I want to do this? Or just the same thing as before, or we'll just put this on a separate line. A cursor move to yeah, that makes more sense. Okay, and then we're going to make that a function in the terminal.c. Cursor move to this will take the term pointer and it will take a u32. Let's make it take just integers, row, column. It's going to clamp the row to be between 0 and number of rows minus 1 possibly. So let me think here. So if basically we need to know like how many I'm gonna just have to like count basically. Oops, let's go back to here. And we will continue. And I'm gonna do this. And I'm gonna do I need to know like exactly how many there are, so let's just so we're gonna ignore the clamping for now, just so that this works when I recompile it. And Let's make this higher for now. Oh, that's interesting. Oh no, sorry, we're drawing too many. This can actually be t to cursor, t to size dot rows, t to size dot height. Oops, I didn't want to spam that. That's not right. Yeah, let's just do too many lines again, just for the sake of this working for this example, that I can actually count and just make sure this makes sense. Okay, so I need this to be broken in a reasonable location. I'll have to reload this. Okay, that's fine. I'll do this, continue, we get there. All right, so, oh, but I can't see that now because of resizing it like that. Right, that's annoying. Let's continue. Let's actually get rid of this one, and I will continue until here. Okay, so let me see. So the size here is a height of 19. So let me do a count here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. But if we're just using zero-based zero-based indexing for the row, then that means that this bottom row here needs to be like -1 in the thing. Okay, so we'll do that. That's in terminal.c. Yeah, that's fine. And then size.column, size.width -1. Oops, I can't actually exit that. That's my bad. No thing there. Alrighty, so that should be good for that. We now have the window size, and we can move the thing around. And I think I'm gonna have to call it there because I'm getting very tired. Have a look. This to do still needs to remain because this is the case where we're stepping the cursor and it's supposed to wrap. It's supposed to wrap to the next line if you go off the edge of the screen. So this cannot be just cursor move to absolute. Yeah. And then this thing is like a similar thing. We're gonna have to do something else here. And this doesn't matter because we're setting it to 0. Okay, so that is good. Now let me just quickly try this again. I don't see why this line count doesn't work properly. Sorry, it does. It just needs to be -1. There we go. Cool. So, and if we just like resize this now, hey, look at that. We're already part of the way towards having scroll back support, which is more than can be said for ST. So if you just if you did this with ST, half the window would just be gone. I can even show that. Oops. Well, go here. Let's move it so you can see what's going on. I mean, ST is also doing like the proper like wrapping, but the main point here is that if you just do this, you don't get the rest of the window. All that data is completely gone. But that just works here, so that's cool. Oh, well, the thing is I actually want to keep this color like this because it's actually like very helpful for debugging. But you're right. Like if I set this color, like we can do that quickly. I'll just comment it out. Where's that? So it is here, clear color. I'll do it just for the footage. Where's the? Or is it like in the cursor? It might be in the cursor thing. Cursor reset. Oh yeah, it's right here. So we are going to take comment that out. 20, 20, 20. Hey, look at that. Got a working terminal. Totally no issues here. Everything here is perfectly fine and works exactly as desired. Let's take the win for the things that I should be taking the win for. Okay. And then we'll add the terminal.c. util.h build, oh wait, sorry, no, I'm looking at there. This I'm going to just edit. I'll just comment out this part of the commit. So I will add vtgl.c and I will just omit this part. Actually, this whole hunk can get removed. Let me see here. Store the window size. Store the terminal size. Actually, just say set the terminal. No, actually, yeah. Set and store the terminal size for yeah, set and store the terminal size. I should probably look if there's some place I need to do that at the initialization. But anyways, so those are perfectly working terminal emulator. No issues here. Thanks everyone for watching. Let's see what's going on tonight. At GTK, I definitely do not want to look at GTK code. Possibly this Jai programming stream. Let me put these on and see what is going on with this Jai stream. Looks like they're doing some sprite sheet stuff. Well, we'll head over there anyways. They're working with Jai. Jai is a cool programming language worked on by, or invented by John Blow, I guess. So we'll go and check out that stream. Let me just set this up here. Let me see here, sorry. Here we go. Alrighty, cool. I'll see everyone next time. Thanks for watching. Bye.